Hello there, welcome to GeeklyEDU Math. This video looks at the squeeze theorem, or also known as the sandwich theorem, and we're going to see how this theorem helps us with finding limits of functions otherwise cannot be found using the limit rules. Now, if you think of the words squeeze and sandwich, well, you might perhaps think that you might have to make your own sandwich here or squeeze your own orange juice in order to understand this theorem or to know what it's all about. But I think after this video, you will see that it's actually quite easier than making your own sandwich and squeezing your own orange juice, although that might seem quite easy. What does the theorem tell us? Well, the theorem of the squeeze theorem, or the sandwich theorem, says if q of x is in between, in other words, if q of x is greater than or equal to p of x, but less than or equal to r of x when x is close to a, except possibly at a, and the limit of p of x as x tends to a is the same as the limit as x tends to a of r of x, so the two slices of bread, you would say, for the sandwich is equal to a value of v, then squeezing in the stuffing, squeezing in your q of x, then you would have then that the limit as x tends to a of q of x must be also then be equal to the value of v. Alright, so that is just the gist of the theorem of the squeeze theorem. And so now we'd just like to apply this theorem in a problem. So in this problem, we are asked to use the squeeze theorem to prove the following limit. So we have the limit as x tends to 0 of x squared multiplied by sine pi over x. We need to show that that is equal to 0. Well, one notices that the limit as x tends to 0 of sine of pi over x really does not exist. Why? Well, because of the division of x there. We cannot divide by 0, otherwise we would have an undefined situation here. However, what could we do? Well, we realize that according to the sine definition, that sine of a value is between -1 to 1. Now, thinking about x squared, well, x squared will always be a positive value. So multiplying both sides by x squared, we find this inequality to then be negative x squared sine pi over x is greater than or equal to negative x squared, but less than or equal to x squared. Alright, so we can see that the sine function is in between. It's greater than the negative x squared, however less than the positive x squared over there. Alright, so now what can we come to? So now we realize that, well, the limit as x tends to the value we are working on here, which is 0, of negative x squared, well, just using substitution, we get that the value here is equal to 0, as well as the limit as x tends to 0 of positive x squared using substitution, that will also give us a 0. Therefore, we come to the conclusion by the squeeze theorem then that it must be that the limit as x tends to 0 of x squared multiplied by the sinus of pi over x must be equal to 0. So that would be the proof using the squeeze theorem of this problem. So I'm sure you might agree with me that that is easier than squeezing your own orange juice as well as making your own sandwich. Quite straightforward over there. So I hope you enjoyed watching this brief video explaining the squeeze theorem as well as the application thereof. I do encourage you to please subscribe to GeeklyEDU to watch many more of other videos and of other topics which you might be interested in. Thank you.